The Heart of the System, a deep dive into the Sun's anatomy and power. The Sun is not just a glowing ball in the sky. It is a chaotic, beautiful, and terrifying nuclear furnace that sustains all life on Earth. At 4.6 billion years old, our star is currently in its middle age, a stable period known as the main sequence. But beneath that steady yellow glow lies a complex layering of plasma and magnetic fields that scientists are only beginning to truly map in 2026. In this three-part exploration, we will journey from the Sun's crushing core to its invisible magnetic reaches. Page 1. The nuclear engine, from the core to the surface. The Sun is divided into distinct layers, each functioning like a part of a massive engine. Unlike Earth, the Sun has no solid surface. It is composed entirely of plasma, a superheated gas where electrons have been stripped from their atoms. 1. The core, the fusion reactor. At the very center lies the core, where gravity pulls matter inward with such intensity that the pressure is 260 billion times that of Earth's atmosphere. Feature nuclear fusion. Here, temperatures reach 15 million degrees Celsius. In this extreme heat, hydrogen atoms are smashed together to form helium. This process, $4.1H to $4He plus energy dollar, releases the gamma rays that eventually become the sunlight we see. The energy journey. A photon created in the core doesn't just fly out. It takes roughly 170,000 years to bounce through the dense interior before it finally escapes into space. 2. The radiative and convective zones. Surrounding the core is the radiative zone, where energy moves outward as radiation. Beyond that is the convective zone. The boiling effect. Think of the convective zone like a pot of boiling oatmeal. Hot plasma rises to the surface, cools, and sinks back down. This constant churning creates the granules we see on the Sun's surface, cells of plasma the size of Texas. 3. The photosphere, the surface. The photosphere is what we see when we look at the Sun with filters. It is much cooler than the core, sitting at about 5,500 degrees Celsius. This is where sunspots appear. Cooler, darker regions caused by intense magnetic activity that inhibits convection. Page 2. The solar atmosphere, the mystery of the corona. One of the greatest paradoxes in astronomy is the Sun's atmosphere. Logically, the further you move away from a heat source, the cooler it should get. However, the Sun defies this rule. 1. The chromosphere. Just above the photosphere is a thin, red-colored layer called the chromosphere. It is visible during a total solar eclipse as a bright red rim. This layer is characterized by spicules, giant flailing fingers of gas that shoot up thousands of miles. 2. The corona, the halo of fire. The outermost layer is the corona. While the surface of the Sun is 5,500 degrees Celsius, the corona mysteriously spikes to 1 to 3 million degrees Celsius. Magnetic heating. In 2026, data from the Parker Solar Probe has confirmed that nanoflares, millions of tiny explosions triggered by magnetic lines snapping, are responsible for pumping this incredible heat into the upper atmosphere. 3. Solar wind. The corona is so hot that the Sun's gravity can't hold on to it. It evaporates into space as the solar wind, a stream of charged particles protons and electrons traveling at 1,000,000 miles per hour. This wind is what creates the aurora borealis, northern lights, when it slams into Earth's magnetic field. Page 3. Magnetic chaos, flares, CMEs, and the solar cycle. The Sun is a magnetic mess. Because the Sun is fluid, its equator rotates faster 25 days than its poles 35 days. This differential rotation twists the Sun's magnetic field lines like a rubber band until they eventually snap. 1. Solar flares and CMEs. When magnetic field lines near sunspots get tangled and suddenly reconfigure, they release massive bursts of energy. Solar flares. These are flashes of light and X-rays. They reach Earth in 8 minutes and can disrupt radio communications. Coronal mass ejections, CMEs. These are giant clouds of billions of tons of plasma blasted into space. If a CME hits Earth, it can trigger geomagnetic storms capable of knocking out power grids and damaging satellites. 2. The 11-year solar cycle. The Sun goes through a cycle of activity roughly every 11 years. Solar minimum. Very few sunspots and flares. Solar maximum. The Sun is peppered with sunspots and frequent eruptions. The flip. At the peak of the cycle, the Sun's magnetic poles actually flip. North becomes south, and south becomes north. We are currently approaching a period of high activity, making the study of solar weather more critical than ever for our digital infrastructure. Conclusion: our life support system. The Sun is the ultimate architect of our solar system. Its gravity holds the planets in orbit, its fusion provides the energy for photosynthesis, and its magnetic field protects us from high-energy cosmic rays from deep space. Understanding the Sun's features isn't just about curiosity, it's about protecting our technological civilization from the very star that gives us life.